Last but not least, we have unknown 8. We got a little bit of TMS in there. Yeah, it looks pretty good. Just a little bit, that's all we need. And I'm gonna try to draw some of this up, and it's not too drippy. Looks good. And it's kind of stinky. It has a familiar smell to it that's not stinky with a little bit of funk on the end. I don't know. There we go. Oh, got it. Good enough. All right, do I have a unique color? I don't think I do. I think I have to find the repeat colors. Do I have red? Oh wait, I don't have to repeat. I got red. Yes, I got red. Okay, cool. So I can invert this. Do a couple times, mix it up. There we go. Put this back here. So all we have to do finally is take an IR of this last number 8. Bring it over to my IR. My zinc selenite crystal is clean. I can just push my thumb. Remember, I'm pushing my thumb on the end of this without a pipette bowl. That'll give me enough liquid. This one looks a little bit volatile, like it might evaporate before I scan it. Let's see. I won't put the metal disc on it because if it evaporates away before it does, we get to see that again. So instrument, scan, sample. Okay. There we go. While we're waiting, look who's watching us. I feel like I'm always being watched in lab. I don't know why. It's weird. These Florence flasks always watching me. The volumetric flasks mind their own business. They don't seem to be looking at me. Just those Florence flasks. Okay, our scans are done. Boom. Oh, look at that. Nice strong signal in the middle. Let me push up and down and see. There's kind of a delay when I squeeze the screen. Oh, there it is, yeah. So yeah, it looks like there's something there. Let's see. And I didn't need to cover the sample. It looks like it wasn't too volatile. It didn't evaporate before I was done. Oh, a little under 3,000. And is this a carbonyl? Let's see. There. Okay. Yep, that's a carbonyl. Got some other stuff over here. Okay, so that one is unknown 8, our last unknown to do an IR of. So I'll save that and I'll start running the NMRs for you. See you in a sec. Okay, I'm going to eject unknown 7 and start on unknown 8, the very last one. So here's unknown 8 with the red cap. Oh, so I'm sticking it in, and I'm going to adjust the height of it over here. Stops. Bring it on over. Let it float in there, and then send it down in by turning off the air, turning it back on, and there it goes. It's spinning good. All right. Close the lid. Go over to the computer, and we'll run it. Right now, I'm in the carbon NMR, so I gotta just type in the proton NMR command and use space H1 enter, and then start the scans. ZG enter. You always start with proton NMR because you need to see if TMS is at 0 and to see if you need to shim it. I wonder what this last one is. I don't remember. We'll see shortly. Oh, looks like the FID's up. Looks a little strange. Maybe I'm going to need to shim. Go over to my nuts program and bring the proton NMR over. I type the letter A and the number 2. Yeah, it's looking pretty good. Let's see. Not bad. It's a little rough here. Let's go ahead and shim it for practice as well. So the shim command is SHIM enter. Relaxation delay 2 seconds. Okay. So what's going on? It's adjusting the receiver gain. So it's adjusting how loud it receives the signals, the detector. Now it's shimming electromagnets C and Y to make the magnetic field as homogeneous as possible around the sample. That 2 second relaxation delay we entered says right here, relaxation delay. That was for how long it pauses between pulses. So it pulses all the radio waves, excites the hydrogens, and then it doesn't for 2 seconds. It just lets them relax and collects the data, and then it pulses again. So that's why you see every like 2 seconds or so you see pop. Let's see if I can get it off. 1, 2. 1, 2. 1, 2. That's about 2 seconds, right? Okay, shims are done. And now I type ZG, enter to rescan it with the newly shimmed magnetic field in the machine. A lot of times students get confused. They don't do that rescan and they come back to AI, and that's right away. And it doesn't look any different because they haven't rescanned. So okay, here's my new FID. Bring it over. This I'm in Zoom subroutine. I'm going to hit enter to get out of that. Now to bring in the new spectrum, I type A2. Oh, looks about the same. A2 didn't change too much. Let's look at the triplet again. Remember we zoomed in there. Yeah, it looks about the same. That's probably just the way it looks. Okay, anyway, so next up is the TMS. Actually, I'll zoom in on it. As you can see, and then if I click and hold, get a horizontal line that cuts through the TMS, type the letter M, my minimum peak height. TMS is currently at negative 0.191. So let's go over to AII and type the command FO, enter. That's frequency offset, and it asks where is it now? It's negative 0.191, I'm pretty sure. Let's check negative. Yep. And then I hit OK, and then it says where do you want it? I want it at 0. Okay. Now I still need to rescan again. ZG, enter, enter. If I didn't rescan, I would just have the exact same spectrum as before. So I rescan it, I check it, and then I wait for it to finish, and then I bring it over the new FID. Okay, I bring over this new FID by typing A2. There we go. TMS is right on 0. Pretty close at least. Let's go. We'll do a minimum peak height. Type M. TMS is at negative 0.020. Close enough. And then I'll switch things up. I'll keep the peak labels this time. So I'll go View, Show Clipboard Text. We'll take that away. Oh, and I got a text box here already. I'm going to zoom in next, actually. Let's zoom in on our signals. Hit enter. Looks like we just have a quartet and a triplet, huh? And then I'm going to type NO to get into the text box subroutine. And I've got this text box over here, so if I want, I can just right click it, change it to 8. Okay, I got that there. I'm still in the notes, enter notes subroutine. I want to hit enter to get out of that, and now I'm going to integrate ID. And its integrals are all already cut up, but if I type C, it clears them all. I do 2 clicks and 1 click, and then 2 clicks and 1 click. I got this integrated. 5 to 8, it's looking kind of weird. Let's set this to 1 and see what happens. I'll go V, I clicked 1 to type V, 1. Okay. So it looks like it's 1 to 1.5. Oh yeah, that's probably 2, huh? Let's go V, 2. Okay. 2 to 3, yeah. 2 to 3 or 4 to 6, something like that. Okay, I'm going to collect this data for you. Now it's time to run the carbon NMR, so I got to get into the carbon setting. I type NU space C13, enter in the carbon settings, and I type ZG, enter, enter. Start those scans. It's going to scan 12 times and collect that data. Okay, the scans are complete. Click OK, and then I'll bring it over to nuts with Control F3, but first I'm going to get out of this integration subroutine by hitting enter. Control F3, enter to accept that default name, 0.5 for line broadening, enter again. Oh, looks like we have a signal past 200 and a couple more, huh? So maybe this is a ketone or an aldehyde. Scroll across our main area, hit enter. Let's, I'll keep the table this time. View, labels are gone. Add a text box, NOA, and this is unknown 8. You'll type more than that. You'll write it more than that on your label, but this is just for mine. You're gonna write your name, unknown number, and date as if you took it. Okay, I got it all there, and I'll just collect it for you guys.